What's up, guys? Welcome back to another video. It's been a long time, hasn't it? I tell you, it's been just crazy. I don't know if you caught my update video, but just all kinds of stuff's been going on, so it's good to be back in the saddle. Today, we are going to be looking at, you guessed it, a motion camera that we're going to create with the Raspberry Pi. So what we're going to do, this is part of that camera module that I showed you. This is just one video. I got some other kind of fun stuff we'll be doing with it. But what I'm going to show you is basically how to build a camera. I don't know if you guys have seen those, but some of those cameras they use like for hunting or whatever, that it has a motion sensor in it. And when anything walks by it, it snaps a picture of it. So I'm going to show you guys how to create one with the good old Raspberry Pi and the Raspberry Pi camera module. So first off, you will need a PIR sensor, which is one of the passive infrared sensors, as it says right here. That's what the data sheet is that I have. The one that I have, I picked up from my local Radio Shack just because I was in there one day for some stuff and I ended up seeing it. And so I was like, oh, that looks kind of cool. We can build something fun out of that for YouTube. So here we go. What it is basically got a little passive infrared device. It sends out an infrared light out of it, and then it senses any changes in that wave pattern. So when something like an object like a person or something walks in that has a different thermal pattern to it, or infrared pattern to it, which thermodynamics will make that happen, different pattern, then it senses it and it registers. It's got two settings. It's got a high sensitivity level and a low sensitivity level set with a little jumper. How this little bad boy works is it's just got a ground, VCC, and I think it works off of 5 volt. What did that say? 3 and 5. Yeah, 3 and 5 volt is what it'll work at. And looks like it's got a little IC on the back, probably some little voltage regulators probably somewhere. I bet you it's a 3.3 chip, so it'll work off a little voltage regulator. Oh, it's got some decoupling caps and some little probably set resistors or something. So anyway, that's how the little guy is put together. Let's see, yada, 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 yada. Got some temperature information, la, 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 and there we go. This is got to be by far the most simple device that I think I've ever played with. The sonic sensor was a little more complicated than this was. It literally, based on movement, will either set this P0 pin, basically you're out, will set it either high or low. So it's low all the time until it sees something move, and then it becomes high. Super simple, super simple. Up here, it shows you the sensitivities. Reduced sensitivity mode for a shorter range, about 15 feet, and then a normal operation for longer range, about 30 feet maximum. So that's that little jumper switch that's right here. You can set, basically, apparently what I'm reading is you can set 15 or 30 feet, so that it will sense. So, and then it has, I guess there's even a calibration. Warm-up time in order to function properly. So it has a warm-up time. It could be up to 40 seconds. Oh, really? Well, I haven't really had much problem with it. And they even give you a little basic program and stuff like that. Ain't that sweet? All right, let's get into it. So let's look at the hardware. I went ahead and downloaded a Raspberry Pi library for the for EagleCAD. So it gives me this great little square here that looks just like the header. The pins match the header on the Raspberry Pi. So this, like I said, this is going to be the simplest one I think we've ever done. So you're just going to take our PIR sensor here. You're going to hook up the VCC. I hooked it to 5 volt. You can hook it up to the 5 or the 3 volt rail. Doesn't matter, whichever one you want to do. So I hooked it up to the 5 volt rail and then hooked up ground to our ground rail and then hooked up our output to GPIO 15. Okay, you can hook it up to any of them. You could do 13 or you could do 16 or 18 or just any of the GPIO pins. It's kind of up to you. This example will do pin number 15. So now what I need to do is we need to set up the Raspberry Pi to actually do this. So what I will do, and I'll show you where to connect up the camera. The camera on the Raspberry Pi, we'll just do the demo video right along with this video. It'll be after this explanation. But the Raspberry Pi connects up the camera to the port. It is a flat flex cable. It's the port that is right behind the RJ45 network port. So for the wired network is where it's at. So let's go ahead and we'll take a look. Oops. Hopefully that's big enough for you guys. There, we may make this bigger. I'm using Cygwin now, and so I got to remember how I can. There we go. And we'll pump this up to like 16, let's say. There we go. Hopefully you guys can see all this when I'm typing. Hopefully that'll work for y'all. All right, I'm gonna go to it now. If you want to know how to connect up the Raspberry Pi, I've got lots of videos in the Raspberry Pi playlist. There's lots of videos that talk about how to set up the Raspberry Pi for networking and all that stuff. How to set it up on a wireless network or a wired network, or how to do that. So what I'm gonna do is I'm going to just SSH to it. It's gonna be Pi. This is using Cygwin, by the way. I've gotten to where I just love Cygwin. Those of you who don't know what that is, that's basically a Linux terminal for Windows, and it's awesome. So I'm going to type in the IP address that I have it at. Okay, and then of course, type in the password. There we go, got it. So now I'm on my Pi. Okay, here I'll run a clear command. So now, with the Raspberry Pi, at least the latest version of Raspbian, which is the image that I have chosen for it, comes with the command that we're going to need to use to get to talk to our camera and whatnot, which is called the Raspi Still, I think is what it is, or Ras Still. Oh, I can't remember what it is. We'll have to look at it in the code. All right, I've created a folder just called Motion Camera on here, and so what we're going to do is I'll just open up the C. So we're going to vim the motion cam.c file. So let's pop that open. All right, so here's the software real quick. I'm just going to do a quick rundown through this. Don't want to bore y'all. This will be available on my project code link. I will SCP the software over to my actual computer and then upload it like I normally do, along with the hardware drawing and whatnot. Plus, I'll put a link in the description to the parallax sensor that I was using. So anyway, first of all, you need to include the BCM2835 library. That's basically the library that allows you to control the GPIO. And yes, we are coding in C. This will be coded in C. And if you want to know how to get that all set up, where to download that package, because it actually is a package you have to download that has all the header files stuff in it. There, I have another video in my Raspberry Pi videos. I may put it up on the corner of this video somewhere. But there's a Raspberry Pi video that shows you how to upload that onto your Raspberry Pi and get that all working so you can control GPIO with the C compiler. All right, stdlib. Yes, I'm going to use this for the system command. Basically, I'm going to call a Linux command from the software here, from programmatically. So I need the stdlib. I also need the stdio because I'm going to print out just some text just to tell me that it's been taken. The picture's been taken. Now I'm going to go ahead and do our pound define. Do our GPIO 15. I'm going to our main function. We're going to initialize our BCM 2835. Then we are going to set up our GPIO for input because it's going to input. This is the input from the PIR sensor. Okay, and then I've just printed, just to make sure it's alive, I just printed hello there, so that way you see it when it starts up. You can easily change that to startup. Come into our rendering loop. I'm going to check to see if the pin went high. If it did go high, then what I'm going to do is I'm going to do a system call. This is the command that you need the stdlib header file for, and it's raspi still. Sorry, that was the command. Raspi still is the command that you're going to use, which uses the Raspberry Pi camera option. Now I'm going to do a -Q for the quality switch. I'm going to set the quality as high as it can go, set it to 5. I'm going to set a -O switch, which is the output file. Where's the file that I want to output the picture to? And I'm just going to name it pic.jpg. Okay. Then we're going to do a -T, which the -T is the time interval. How long do you want it to take the picture, essentially? And this is done in milliseconds, so I've put a 1 there, so it will take a picture in 1 millisecond, is what it will do. And then the -TH is the threshold, I believe. Stop me if I'm wrong. I may have to look that back up. But basically, what it is you can do like a basically kind of like a time delay type deal. So if you want to do, I can't think of the name of that, what that's called, but basically when you want to take something in like an elapsed time, you want to do like an elapsed footage where you take a whole bunch of pictures over a course of time or something. That's where that piece comes into play. I could look at res still. Let's look at it. Where is the TH option? Let's see. Okay, for some reason I am just not seeing it today. There it is. Thumb. Oh, I'm sorry. Totally off. It was the thumbnail parameter. See, you know, you do this stuff so long and then it pretty soon it just fries your brain. So it's the thumbnail parameters. So how big the thumbnail needs to be and the quality of it. Okay, so I just set it as nothing, so that way there is no thumbnail, is what I set, if you want to look at it. Okay, TH is 000, so I'm setting it just to 0. Basically, there's no thumbnail. Sorry, I couldn't remember. I think the elapsed thing is when you're doing, there's a way, I've done two things, and I'll be showing you the next video. There's a way that you can actually create kind of almost like a video, like a running video, where it basically just starts snapping pictures and uploads and puts it in this pic JPG, except it changes every so many milliseconds. And I can't remember how, I've got the code somewhere else. That's going to be the next video. So, spoiler alert, that's the next video is going to be about, is how to make a movie using this RasStill deal, and basically take that movie and do a live stream over a web page. That's what's going to be the next video. So, spoiler. Anyway, and then I just print it made it, so that way we know that it actually took the picture from the console. Then what I'm going to do is I'm going to issue just a while statement that will wait till the PIR sensor gets reset. Otherwise, it'll just be snapping pictures one right after the other. So I'm just going to do a while on that pin. So while it's still high, it's just going to wait. And the minute it goes low, it will bounce out of here. It'll delay 10 milliseconds so that the PIR sensor has a chance to reset and warm back up and all that fun stuff. And we'll be good to go. So I'm going to quit out of that. So basically what you're going to do is you will do the GCC-O. Let's see, hold on. Let me remember what I named it. To compile this, you'll GCC-O, and you'll name the output file, which or the output exe, which I'm just going to name it motion cam. And then you'll give it the source file, which is motion cam.c. Hit enter. It'll compile. I've got some undefined references, BCM and NIT. Looks like we got some stuff to fix. Oh, no, I know what it is. I didn't put, silly me, haven't compiled this in a while. You have to do a -L and point it to the BCM 2835 library. I forgot about that. There we go. See, that's why I got this undefined reference to all this stuff, is because it didn't know where to find the header file. So you have to do a -L BCM 2835, and that's the same. I'll show you where that all gets set up and how to do all that in that other video that I'll probably put a link or something to, on how to set up C programming for at least being able to talk to the GPIO with a C program in the Raspberry Pi. So once that's all finished, you just do a ./motion-cam, and you'll hit enter. Well, you got to do a sudo first. Permissions. At least it's not like Windows and asks you 800 times if you want to do it. Okay, and there we go. There's the hello there. And then I'm sitting at my chair. It's actually on my workbench. I'm going to wave at it. If I can get it to do it. See? There we go. It made it. So now it just took a picture. Hey, I took another picture. I'm still wiggling around over here. So anyway, so now we're going to go ahead and we'll go over to the bench and we'll check it out, and I'll show you how it is all put together. So I'm going to cancel it for now, and we'll switch videos. Be back in a minute. Okay, guys, what's going on? All right, we're at the bench now. So what I've got is I've got my pan vise here set up, and I've just kind of chucked up the camera in it. Here, I'll turn it over and I'll show you. So I got the camera module is right here. So there's the little camera. Okay. So we got our camera module in. I've got the wireless dongle in it, so I don't have to have a big network cable hauled over here. But if you can see that, let me scoot that over to the side. That's the connector. Let me see if I can grab the camera. Zoom in here. There we go. See, there's where the ribbon connector goes. So there's the wired Ethernet port. As you can see, there's the wired Ethernet port, and it's the connector right behind it. All you got to do is pull up on this little clasp that's right here, and it pops up. You slide the little ribbon cable down in there, and then you just push that little clasp back down on there, and it'll connect it. So pretty straightforward and simple. All right, right next to it, let me back up a little bit. Right next to it, I've got the PIR sensor. Now, I've got tape around it. Let me explain why I did that. Put the tape around it because it has basically peripheral vision, and so if something is like, way off to one side, like way over here, essentially, and it's moving, it'll see it. What I wanted it to be when something gets right in front of everything, when something gets right in front of the camera, basically right in front of the sensor, then it will see it and take the picture. So that's the reason I've got some tape around it. You could easily take, I don't know, maybe a cardboard tube of some sort, or maybe a piece of PVC or something, and slide it over the end of the sensor, and then that way it would make it where it wouldn't get so much stuff on the sides rather than right in front of it. So anyway, we got this hooked up. Just like we had it, pin 15 or GPIO 15, which is this pin right here. We've got our power and ground. So now we'll see how it works. We're gonna basically back up here, and I'm going to see if I can't wave in front of it and take a picture. I may move the camera around to get set up so we can see it. So what I'm gonna do, let me see if I can do that. Let me handheld this. Sorry about that. We'll go like this with it. All right. So that way maybe you can see it. So inside on the PIR sensor, you can see it light up when something moves. So I'm going to move my hand in front of it. See it? See it light up? So it just saw me. Now it's reset. So it takes it a little bit to reset. Now if I move again, woo, there it goes. See it lit up? All right. So now what we're also going to see when I back up like this, what we'll see is when I move in front of it, not only will it light up, you'll see there's a little LED right here. Let's see if I can zoom in on that. There's a little LED. Oh my goodness, that's blurry. Focus. There we go. There's an LED right there. And that little LED will light up when the camera is actually taking a picture. So let's watch that work. Let me see if I can't not shake the camera too much. I apologize for that. I know it's really bright. We opened the blinds over there. All right, so I'm going to go over here. Sorry, I'm looking in two places. I got to grab my keyboard. Just a minute. All right, I got it. Okay, so I'm going to go ahead and start this. Let's see, I need the pseudo version of it. There we go. Okay, so I'm going to go ahead and start the program. Got it started. Oh, did you see the light up? May have taken a picture. So what we're going to do is we will take a picture right fast. And it'll probably be a picture of me holding the camera, but more or less it'll work. So there we go. All right, now we're going to go ahead and we'll download the picture. So back to the drawing board, so to speak. We'll download the picture. Okay guys, we're back at the drawing board here. We're back to the computer, and we were going to download the image. So to do that, I like to use a program called WinSCP. I'm going to actually open that up right now and show you what it looks like. Okay, so I've got a login here. I've got some other stuff that I log into, but the Raspberry Pi is one that I have, and I got the IP address typed in, port number 22. And so we're going to open that up. It should connect. There we go. Type in our password. Whoops. There we go. And it should bring it up. Okay. Now what's awesome about this is you can just slide it from one place to the other. Let's go. Okay. Like right now I've got the motion camera, and there's the pic. Okay. So there's the picture that we took. I've obviously been looking in this, but normally it'll start up and it'll just be in like the home folder or whatever. And like I said, I made a motion camera folder, and that's where the pic is. All you gotta do is literally just click it and drag it to where you want it to go, which I just drug it over to my desktop. So now, get out of the way here, minimize all this stuff. Let's move this over where I can see it. There's the picture. And there we go. Me in my 1UP shirt. So the quality, it's a little red. So I mean, I think there's some other settings and things that you can do to actually set the tint and whatnot. But that's basically the rough way of doing it. I showed you just the basic way of getting a picture to work. So there you go. There you have it. The Raspberry Pi and the Parallax PIR sensor. So as always, guys, thanks for watching. Like, subscribe, share, and all that fun stuff. Check me out on Twitter. I like I said, I try to post on Twitter what's going on. Like even when I couldn't get a video up, I was kind of letting you guys know what was happening and what was going on. So check me out on Twitter, as well as check me out on Instructables. I usually post most of my videos to Instructables. Plus I do little contests and whatnot over there at Instructables. Also, in the works coming up, I think we're going to do probably a question and answer live stream. Let me know what you guys think in the comments. I really, really want you to engage in this. I usually don't get a lot of people responding to my questions, so I would really like for you guys to respond to this one. Let me know what you would think about having a live stream. Is that a good idea? Is it a bad idea? If you can use live in your comments below, that would be great, so that you're alive or you're having a great life or whatever. Just use live or life in your comment below would be great. I know that you made it all the way to the end of the video. And take care, guys. Check out also Zazzle. I think I uploaded one more t-shirt. I think I'm going to do some more. I've got 3 or 4 in the works. However, I've got someone that's going to help me with doing the artistic design, since I am not artistic whatsoever. So that will be coming up as well. Take care, guys. Hope to see you on the next video. Please leave comments below. It'd be awesome. Leave me a like too. That really helps the channel. Take care and keep coding and building electronics, because that's where the fun really is, and that's what makes everything worth it. See you guys later. Have fun, and that ought to do it.